All right, on this video, now we're going to throw in variables, and we're going to find the GCF of variables. Now, remember the C in GCF stands for common. So if you want to take a greatest common factor of variables, they have to be the same variable. You know, you can't have an X and a Y. Now I'm going to relate this to when we came up with all the factors for the numbers that's given. Now if I have X cubed, I'm going to rewrite X cubed. If I write all the factors, well, all the factors of X cubed, there's 3 factors of X. This is the same thing, X times X times X. This X squared, well, that's, if I write out all the factors, it's X times X. And for this X, well, there's no real factors to it. You only have one X, so I'm just going to list X. Now, if you look at this list, these are all the factors. Now, the only thing that they have in common, in these 3 lists, they only have one X that's common. This has one X, this is in common, this is in common. So we say our GCF for this is just X. It can't be X times X or X squared because this last term, there's only one X. So what we learn from this, when you find the GCF of common variables, here's the main thing. This is very important, so make sure you take this down. Take the smallest exponent. So you don't have to write out the X times X times X. Here's a shortcut. Just take the smallest exponent of the common variables. So here we had an exponent of 3. This is an exponent of 2. X is the same as saying X to the first. So the smallest is at 1. So X to the first, that's the GCF, which is the same as just saying X. Okay, let's move to number 2. Now number 2, I have 3 terms. X cubed y squared, X cubed y, and X squared y cubed. They all have X's and Y's. So if they all have X's and Y's, I'm going to have an X and a Y in the GCF. What I don't know is, what is the exponent going to be? Well, as I learned from the previous example, let's take the smallest exponent. So for all the X's, I have a 3, I have a 3 here, and I have a 2. This is the smallest one. So X squared, that's going to be in the GCF. Okay, then if I look at the Y's, I have Y squared. This is the same thing, Y to the first, and Y to the third. The smallest is this, Y to the first. So I can just erase this question mark because Y to the first is the same as saying Y. So that's the GCF. All 3 of these terms, they at least have 2 X's and they at least have 1 Y. So that's the greatest common factor. Okay, and let's do number 3. Okay, when I do number 3 for the GCF, well, let's look. All 3, they have X's. So if I have X squared, X to the 4th, and X cubed, the smallest exponent is this, so I have X squared. Okay, and then the other one, let's see, I'm done with the X's, so I'll just cross them out. They all have Y's. I have Y squared, Y to the 3rd, and just Y. Well, this is the smallest, that Y, so it's just Y to the 1st or just Y. So I'm done with the Y's. Now, you might think we have to put Z in the GCF, but remember C, that stands for common. This has a Z, this has a Z, but there's no Z right there, so I'll put a question mark. So the Z, it's not going to be in the greatest common factor because that last term, this X cubed Y, there's no Z there. So I can kind of disregard it. So this is my GCF, X squared Y. So when you're just dealing with variables, all of the terms have to have the same variable, and then if they do have the same variable, then you take the smallest exponent for each variable.